A gas is taken through the cycle process described in figure. You know, we have a clockwise cycle. Clockwise cycle. A, B, C. We start, we go A, B, C, A. Clockwise cycle. Find the energy, the net energy transferred to the gas, to the system by heat during one complete cycle. So we have to find delta Q of one cycle. Okay, let me explain one point. In general, in the case of cycle, you can go clockwise or anti-clockwise. Okay, like in this case, you have clockwise cycle or anti-clockwise cycle. In the case of clockwise cycle, or in general, for any cycle, we have delta U of the cycle equals to delta Q minus d omega. This is the general expression of first law of thermodynamics in the case of one cycle. Delta U of cycle equals to O. If we have clockwise or anti-clockwise, delta U of the cycle equals to O. The change of internal energy of any cycle equals to O. So dq equals to d omega. In the case of clockwise cycle, delta Q cycle must be positive. So d omega of the cycle must be positive. In the case of anti-clockwise, delta Q of cycle is negative and d omega of the cycle is negative. Here, be careful, I am using omega by, the calculation of omega by, where delta omega equals to the integral of p dv. If I ask you to calculate the work done on the gas, you know omega on equals to minus omega by. So equals to minus integral p dv. In all the expressions here, we are using omega by the gas. Omega by delta U equals to delta Q minus omega by the gas. And the calculation of omega on, it will be via the omega by. Anyway, here I ask you to find delta Q of the cycle. So as we have a clockwise cycle, delta Q must be positive, which is equal to d omega. And here I have nothing to calculate. I don't have a numerical value. You go here to the figure, you have VA equals to 6, VB equals to 10, PA equals to 2, and PB equals to 8. How can we calculate omega? You know, in the case of cycle, the total work of the cycle equals to the area inside the path, inside the curve. So equals to this area. Okay, you know, it's a right triangle. The area in general here, we can say area of this right triangle equals to this side times this side divided by 2. Okay, so this side equals to delta V from here to here equals to 10 minus 6. Okay, so we have 10 minus 6. This side equals to 8 minus 2 divided by 2. We get here 4 times 6 divided by 2 equals to 12. 12, this is the area here. You know, here we have a clockwise, so omega must be positive. So we can say dq equals to d omega equals to 12 joule is positive. The second part, I ask you, what if the cycle is reversed? It means we are going anticlockwise from ACBA. Okay, ACBA. What is the net energy input per cycle by heat? So I have to calculate the heat if in the case of anticlockwise cycle. You know, in the case of anticlockwise cycle, delta omega equals to delta Q must be negative. Anyway, the area will not change. We have the same area, but it must be minus 12 joule. Okay? We don't have any change about the area. We have the same value. The only value, the only changement will be the sign of the energy, positive or negative. It's very important to know 2 points. First of all, the work is the area of the closed area between the curve, inside the curve. The second point, omega is positive and Q is positive in the case of clockwise motion direction and is negative in the case of anticlockwise. Second part, part B, if Q is negative, QBC is negative. I give you QBC is negative. And delta U CA is negative. I want to find the sign of Q omega delta E for each process. So here we have B, C, C, A, and AB. I want to find omega of delta omega, Q and delta E for each one. First of all, I give you QBC is negative, delta U CA is negative. Okay, we start. First of all, you have to know in the case of if we increase the volume, omega must be positive. Let me write the general expression of the first law of thermodynamics. You know, delta E equals to delta Q minus d omega. D omega. Okay, you can say delta. Okay. Here, you know, we are using omega pi, where the omega equals to the integral of P dV. This is a work done by the gas. by the gas. Okay, first of all, in the case of BC, here we have a constant volume, so d omega must be equal to 0. In this case, dE equals to dq. dq is negative, so dE must be negative. Okay, so we can say dq negative, so dE must be negative. dE is negative. Okay, and d omega equals to 0. This is about BC. Now let's take CA. In the case of CA, you know, we decrease the volume. We have a decreasing of volume from the point C to the point A. As the volume decreases, you can say directly omega is negative. Omega of delta omega, okay? D omega CA must be negative. So delta omega is negative. Delta omega is negative. You can write, I want to calculate delta Q. Delta Q equals to delta E plus delta omega. Delta Q, delta E plus delta omega. Okay, you know, we have delta E is negative, d omega is negative, so delta Q must be negative. Okay, we come to the state AB. In the case of AB, we increase the volume from the point A to the point B. So omega must be positive. So d omega AB is positive. Why? Because volume increases. So d omega is positive. What about dq? Here you can use one equation. You know, delta E of a total cycle, you have to know in the case of cycle, delta E of the total cycle equals to delta E AB plus delta E BC plus delta E CA. Okay, AB, BC, CA. And also delta omega delta omega of one cycle equals delta omega AB plus delta omega BC plus delta omega CA. Okay, first one, delta E total equals delta E BC is negative, CA is negative. In order to have delta E of the cycle equals to O, okay, you know, delta E of any cycle equals to O. Delta E of any cycle equals to O. In order to have a zero delta E AB must be positive. We have positive value and negative value. The total value must be negative. So delta E must be positive. You can apply, in the case of AB, delta Q AB equals to delta E AB plus d omega AB. we have delta omega is positive, delta E is positive, so we get delta Q must be positive. Okay, like this, you have to know the physical meaning of each process. Like this, you can understand very well the evolution, or for any process, how you can get a positive value or negative value. In the case of any mistake, you can know your mistake. I repeat again, here we are calculating omega by the gas, omega, the work done by the gas, for each one. In the case of BC equals to 0. In the case of CA, the work done by the gas is negative, and the work done in the case of AB by the gas is positive. Okay,